We have an operational amplifier and an adder-subtractor configuration with multiple inputs, and we're going to analyze it. That's coming up right now.
Hi, I'm Dr. Bob. There are no lectures here. I just solve problems, homework problems to help you understand how to do them. Electrical engineering at your service.
This is an adder-subtractor OpAmp circuit, and we're going to analyze this. Basically, we're looking for, this is part A, we're looking for V sub in, V sub P, V out, and I out. And what these are, V sub in, V sub P are the inputs, as you can see, this one right here, and that's V sub P, those are the inputs to this OpAmp. And V out is the output. It's right here. I out is this current going this direction. Okay, so what we're going to use is KCL to solve this. And we're going to write three equations. The first one we're just going to write around V sub n. This is going to be V sub n minus V1 divided by 10K plus V sub n minus V2 divided by 35K plus V sub n minus V out divided by 210K ohms, which is this leg right here, and then plus I sub n, all that adds up to 0. And then we have a second equation here, number 2. We're going to take this at VP, so we're V sub P minus V3 divided by 15K ohms plus V sub P minus V4 divided by 6K ohms plus V sub P minus 0 volts, which is ground over here, this is the last one, divided by 21K ohms plus I sub P equal to 0. Now the third equation is around V out. It's this one right here. So we have V out minus V sub n divided by 210K ohms plus V out minus 0 volts, which is this leg right here, divided by 105K ohms plus I out equals to 0. Okay, so here are three main equations, and probably the easiest one to do first is going to be equation number 2, because here we can solve directly for VP. And in this configuration, as long as the OpAmp is balanced, IN and I sub P should both be equal to 0. It's not exactly equal to 0, but very near to 0, so it's intended to be very high resistance or very high impedance input or very high Z. So we take that input to be pretty close to 0. So let's take equation number 2. We're going to multiply everything in these equations. I think first I'm going to clean up these equations by just multiplying everything through by 210K ohms. Let's clean up these two, equation 1 and 2. Let's see, the first equation is 210K over 10K. It's just going to be 21 V sub n minus 21 V1 plus 210 over 35K comes out to 6 V sub n minus 6 V2 plus 210 over 210 is just 1 V sub n minus V out, and all that adds up to 0. And let's clean this up again. What we did is you add common terms. We get 28 V sub n minus 21 V1 minus 6 V2 minus V out, V out equals to 0. And that will be, that's going to be our main equation 1 without adding any voltage, because we know what V1 and V2 are, so we could just turn this into a number. Equation 2, when we multiply that by 210K, what we get is 14 V sub P minus 14 V3 plus, this is going to be 35 V sub P minus 35 V4 plus, and that's going to be 10 V sub P. All that equals to 0. We clean this one up and add common terms, and here we get 59 V sub P minus 14 V3 minus 35 V4 equal to 0. All right, that's our second guiding equation. These are the equations that are basically going to give us our solution. So we're not going to look at equation 3 just yet. We will in a minute. But we're going to take these 4 values here. V1 equals to 1/3 volt. That's a 3. V2 is equal to 0.4 volts. V3 is equal to 0.5 volts. And V4 is 0.2 volts. So we plug these numbers in. The first place to plug this in is going to be into 2, because 2 right away we can get a value for VP, and that'll give us one of our solutions. So we get 59 V sub P minus 14 by V3, which is 0.5 volts, minus 35 times V4, which is 0.2 volts, equal to 0. And of course this 7, that's 7. So we get V sub P is equal to, when we solve this out, V sub P equal to 0.237 volts. Now, in a balance, this is our first solution. In a balanced op-amp, the V sub P is going to be equal to V sub M, which is also equal to 0.237 volts. And so this is the second solution we're looking for. The third thing I guess we're going to look for is V out. We get V out from, so we're going to get V out from this equation over here, since we know V sub N. So let's plug those numbers in. We have 28 V sub N minus 21 V1, so we're going to write that down. So plugging in for V sub N, we have 28 by V sub N, which is 0.237 volts, minus 21 times 1/3 volt, which is V1, minus 6 times 0.4 volts, minus V out equals to 0. Okay, so we can multiply all these numbers out, and I'll let you do that. And what you get for V out, we get a negative value. Once you work out, V out is equal to negative 2.76 volts. Okay, so that's 3 of the 4 variables. Now we want to know I out, and that's when we go back to back to equation 3, which was V out minus V sub N divided by 210K ohms plus V out minus 0 divided by 105K ohms plus I out equal to 0. So now we just plug those numbers in. We know V out is minus 2.76 volts minus Vn, which is 0.237 volts, divided by 210k ohms, plus negative 2.76 volts divided by 105k ohms is equal to minus I out. And of course, all these are negative when you add them up, and we get you can add them up, get I out equals to 38.3 microamps. And that's all of part A. That's all for the things we've been looking for.
Thanks for watching my program.
If you like my videos, be sure and subscribe to my YouTube channel. And for an organized listing of my YouTube videos, go to my website, www.wherearemyplacebos.com, and click on videos. Have a great day.